We are Fancy Pants, and we are designing a device to assist wheelchair-bound people in the process of putting pants on from start to finish. Here we see some of the methods and devices people use to put pants on while in a wheelchair. First, they need devices to help with their reach to their ankles and help pull up the pants. They also struggle with getting pants over their hips as seen in the second image. There are three main steps when putting on pants. The first would be to get pants over the ankles and allow them to be pulled up. This is often done with devices such as the Wings Pants dressing aid. The second step is to pull pants up to the hips. Customers must be able to support themselves while pulling up the pants. The third step is to get the pants over the hips. Without assistance, customers must wiggle side to side to put their pants on, or they must use a device such as the Pants Up Easy shown below, which provides support with their arms. While researching our customers, we found solutions that solve parts of the dressing problem, but never the whole process. The first example is the Wings Parents dressing aid, which helps with the beginning process of dressing, but not getting the pants up and over the hips. The second example is the Pants Up Easy, which helps supports the customer and gets the pants over the hips, but not with the beginning part.
Shown here is our design specification matrix. Once we had a good idea of how we wanted to define our problem, we moved toward considering some things that the customer would need out of our product. Some of the main customer requirements that we came up with were that the product is safe, it's affordable, and that it caters to leg spasticity, which is when the leg muscles contract, making them hard to bend or move. From there, we generated some functions that the product must carry out to achieve these customer requirements. These included adjusting to the user's body type, supporting the user, and releasing the user back into their wheelchair safely. These product functions were used to come up with our engineering characteristics and their target values. We used the rankings from the House of Quality and our own intuition to decide which of the ECs were important enough to be used as design criteria. These are those design criteria. The first 5 came from our ECs. These were time to use. The product must be the product needs to be complete the process reasonably fast. We are aiming to keep the time to use under 1 minute. Durability, this should be a long-term product, so we're hoping to have a product lifetime of about 25 years. Adjustable size, the product must work for as many types of people as possible, so we're designing for people of heights ranging from 4'10" to 6'4". Footprint, the product can't take up too much space in the user's home, so we're aiming to keep the footprint under 6 square feet. In weight, the product needs to be reasonable to move around, so we're aiming to keep the weight under 50 pounds. The other 2 design criteria weren't ECs, but we deem them just as important as them. So these 2 were cost. Nathan discussed our main competitor being Pants Up Easy. It solves our problem pretty well, but it's just too expensive. They have a price of about $1,000, so we're aiming to keep ours under $800. And then the last DC is percent of the process it assists. Nathan discussed the 3 phases of putting on pants. So we want our product to assist in all 3 of these phases, so it's an end-to-end solution. We focused on these DCs in determining how well our concepts would solve our problem, both by keeping them in mind when generating the concepts and plugging them into our Pew chart in AHP.
We will now move on to the concept development and selection process. To start off, we looked at the designs we had come up with for the concept development homework assignment. We then reviewed over each group member's 10 concepts and decided to take the best designs from each by compiling them into a singular document, imitating a morphological chart. This slide shows the best concepts taken from our concept development assignment. Because these designs are only supporting a singular function, we needed to add more to each design to create a full concept. From these 10 concepts, we decided to form 6 concrete concepts that integrated some of the original designs together. After we decided on these designs, we were each assigned to draw up 2 of the 6 concepts. We placed multiple group members on each design because we wanted different interpretations of each concept. I will now go through each of our complete concepts. For our first concept, we combined a holding system, which is attached to the user's pants. It can keep them open while supporting the user. and contains a rail next to the user's leg to make hoisting up the pants easier. Our second concept is a suspenders design that can hook onto different parts of the pants and pull it up more easily over the user's ankles, knees, and waist. One of these designs allows the user to control the movement of the pants, while the other is mechanically controlled. The third concept is a bar that hangs in front of the user. The bar system is attached to the user's pants so that they can pull up on the bar in front of them and hoist the pants behind them. The fourth concept is a leaning support that can help the user out of the chair and support them while making it easier to load their pants. This allows the user to reach down and put their pants over their ankles, even if they can't bend their legs. Our fifth concept combines this leaning support with an in-chair support system, lifting them up while still in their chair. This makes it easier to pull up their pants to their waist. One of the designs uses a seatbelt to secure the user and allows them to lean over and reach their feet, while the other design secures the user with a bar and is adjustable to height and waist size. Our last complete concept combines the leaning support with an over-the-shoulder strap that would attach to the user's pants and allow them to pull it up due to their own leverage.
So we decided to use the Pew analysis chart to compare and own in on our top three concepts. So on the left-hand side, we have the design criteria for which we would be comparing to Pants Up Easy, which is our baseline. So on the right-hand side, we have our 6 concepts, and for each, a plus sign means that we believe our concept does better than Pants Up Easy for the given design criteria, and the negative means the concept does worse than Pants Up Easy for the given design criteria. So as you can see, our top ranked designs would be railing support and guide, tied with the bent over in-chair support, and then closely in our third place would be the leaning over shoulders pull-up. So our bent over, our railing support and guide stands out in the cost, weight, and footprint, particularly because it's small and it doesn't have a lot of material, so it can be made pretty easily. It has rails to guide up the pants, and the idea is that when you sit on these rails, your butt and thighs area is making less contact than if you were sitting in a flat seat. So there's a little bit more leverage to wiggle around and get your pants up to your waist. So for the bent over in-chair support, this concept is distinct in that it combines leaning support with an in-chair support, which lifts the user in the air and allows them to pull their pants up to their waist much easier. And for the leaning over shoulders pull-up, they're similar, but it's also distinct in that it combines the leaning support instead with a shoulder strap. This strap attaches to the user's pants and allows them to pull up the pants as they're leaned over, using their own body as leverage.
Now that we have these final 3 concepts, we will use the HP process to select a final one. The first step of this is weighing the decision criteria. We first rank them from most to least important to help us with our consistency check. We then use the matrix shown on screen to compare them, with the numbers greater than 1 showing how more important they are up to 9. So for the fractions, that means that the DC is less important than the corresponding one. Here are our results from the first part of HP. Cost and percent of process it assists are the highest weighted at 32 and 29%, followed by time to use at 16%, both durability and adjustable size at 8.7%, and finally footprint and weight at 2.6%. We can then use these weights to complete the second part of HP. In this part, we take each DC and rank how well the final 3 concepts meet these. On screen is the completed AHP. As you can see, we went through each DC and ranked the 3 concepts against each other. These concepts being the railing support and guide, bent over in-chair support, and the leaning support with shoulder straps. Here is the final 3 matrices for the remaining DCs. This brings us to our final results. We multiplied the weights of the DC with the weights of how well the concept met them and added up all of these 7 products for each concept. We ended up with 2 concepts that had very close final results, with the bent over in-chair support at 0.391 and the leaning support with shoulder straps at 0.386.
After we finished the AHP, we also had to take human factors into account to make our final selection. The main human factors are strength, reach, flexibility, and simplicity. For strength, the customer must be able to support themselves with the assistance from the device. They need to be able to reach their ankles with support from the device, be it a reach aid or a bar helping them with support as they lean down to reach their ankles. Finally, the device should be simple to use. The customer should be able to look at it and know how to use it without training.
We ended up choosing the bent over in-chair support to be our final concept. It was only slightly higher than the other option in the HP, but there was one major benefit to the in-chair support that is not represented in the decision criteria. This is that it allows the entire process to be completed while the user remains in their chair. This is why we have chosen this as our final concept. In the last section, Ryan will go over in detail what exactly this concept is.
The key component is this U-shaped set of cushions that provide support for leaning over, marked leaning support, and underarm supports designed to comfortably hold the weight of the user, labeled underarm support. The use of these features will be captured in the following sequence. This U-shaped support begins connected to a wall or stand with the pivot point behind the user and above their head. Depicted here, the support is connected to a wall. Additionally, the support initially starts parallel to the ground as shown. When the user is situated properly below the support, it will rotate down until the leaning support rests gently on the user's lap. Then the user will be able to shift weight forward to assist with placing the pants over their feet. Next, the user will place their arms over the underarm supports. The support will then rotate slightly up, allowing the user to hoist their pants from the knee to the waist easily. Finally, the support rotates back down, placing the user back in the chair, and the support returns to the initial position. The integral architecture of the support, performing all required functions, is a great strength. While currently the shape can be described as a U, this can be built upon to make the support more ergonomic. Additionally, the cushions could rotate to allow for even more comfort while moving in the support. Another key strength is that the user does not need to leave the chair to enter the mechanism. This is a major factor in selecting this concept, however, it presents challenges. When the cushion lifts, the user's horizontal motion must be controlled. The team does not wish for the user to slide in the support or be placed down uncomfortably in their chair. Two mechanisms can be employed for this. First, the cushion itself could extend and retract as illustrated. As you can see, the horizontal distance D is maintained. This could also be mitigated by the pivot itself moving horizontally. Again, see that the distance D is maintained. Another topic to explore is actuation. The mechanism would most likely be actuated electronically using a motor, which is extremely programmable. If electricity should be avoided, the driving force would come from a spring damper system as shown here. In this case, a spring would force the system to rotate, forcing air out of a channel. The air pressure in the channel should keep the system critically or overdamped. In any case, the team must prevent the system from becoming underdamped for the comfort and experience of the end user. Ultimately, this design satisfies all of the major decision criteria while outperforming Pants Up Easy at a lower cost.